everybody, welcome to another Agile IT Tech Talk. This is your host, Sean Spicer, head of marketing over here. Today I am joined by Miguel Escalante, our cloud solutions engineer and resident mad genius. I think you used the term Dr. Evil a number of times yesterday going over what we're going to discuss today. How you doing today, Miguel?
I'm doing great, Sean. How about yourself?
Doing all right. A little bit of a raw voice still, so bear with me if I cough or make weird whimpering sounds today. But today we're going to be going over infrastructure as code, which is some really interesting stuff. Miguel was finally able to get it through my skull yesterday what desired state configurations are. So he'll be explaining that as well. So I'm going to go ahead and let Miguel take it over. Just a reminder, though, go ahead and ask questions in the question pane, and we'll answer those after the recording ends and after the session and demo.
All right, Sean, thank you for teeing that up. So let's start off by the basics, right? What is infrastructure as code? Well, traditionally IT, you were able to request a server from your IT department. You know, they need to go back, get resources, or explore if there are any resources available. Spin up your box, install your apps, make sure the drive configuration was what you requested, make sure that the add-ons were there. And if it was a group of servers that you wanted to deploy to for a distributed application, well, that just made it all that much more complicated. Right now, with cloud services, you can basically spin up a box in a matter of minutes because you don't have those resource limitations. That's where infrastructure as code comes in. Infrastructure as code is a declarative document written in JSON that Azure can interpret, and you can parameterize it in such a way that you can build as many machines as you want using a cookie-cut template, or you can actually customize it to an entire solution. So you can actually deploy an ARM template to deploy something as complex as Uber. You can actually not only deploy VMs, you can deploy any cloud resource you want. It can be a SQL database, it can be a website, it can be a load balancer, you name it, you can do it. It's all in code. Cool thing about this, it also allows you to source control the information. That means, let's assume that you have an application that you're releasing and it requires a certain server footprint in Azure or infrastructure in Azure. Well, you would be able to deploy it using a template. And later on, it evolves to needing something additional, maybe a load balancer. Maybe you've now made a global traffic manager aware. Well, you just add that additional infrastructure piece to the template, and you're always compliant. You can actually publish these to the marketplace for stuff that you want to reuse back and forth, or a custom specialized application that you want to do. It's written in JSON, which is universally acceptable as as language, and you can manually do it, meaning you can manually create these, or you can do you can type them up in Notepad, or you can actually do it through Visual Studio. There's an Azure writer or editor, but it really is a little bit not, Visual Studio is a little bit better. Now, as far as deployment goes, and we can keep this slide, Sean, it can be deployed via the Azure template, create template add-in, or it can be deployed using Visual Studio, or it can be deployed using PowerShell. So a number of methods that we can get our code out there. Now, what really makes this powerful is the next component, which is desired state configuration, because not only are you deploying a machine or any type of infrastructure, but for particularly a VM, nobody just deploys a VM to Azure just to deploy a VM. It needs to have a purpose. It needs to have a function, right? I don't know of anybody that goes out there and just like, oh, I feel it's, Thursday afternoon, let's deploy a VM just for fun. You usually are putting Exchange, you're putting Active Directory, you're putting something on top of it that'll serve as a module or a solution to something else that you're running, right? So desired state configuration allows you to do that. In the same way as you're doing an ARM template, it's a declarative file that is written in PowerShell. It allows you to say what that machine is based on whatever characteristic you decide to use it against. It can be something as subjective as if I created a directory on the C drive called Exchange, it'll install Exchange Server if your configuration says so. Or if the VM name contains the part SQL, deploy SQL to it. Not only deploy SQL to it, but deploy SQL to it in a certain way, meaning that it'll actually ensure that it has a certain drive layout. There's certain folders in those drives. SQL will get down, the binaries will get downloaded from a download location. It'll get installed in a certain way. And then the cool thing about this is that every 15 minutes, the local configuration manager, which is built into PowerShell 4.0 and above, will go in and say, well, is the configuration once you set the LCM in motion, every 15 minutes come back and checks up and says, well, is it what I'm supposed to be? That's what makes the configuration drift stop. If someone goes in there, and let's assume that for SQL Server, okay, you need .NET Framework 3.5. Let's assume that someone was in there adding an additional application on top of it, and they decided, well, I'm not sure what this 3.5 is doing here. Might as well remove it. You can. That's perfectly fine. It'll allow you to do so. But if you come back 16 minutes later, it'll be back in there again. Why? Because you specified that the .NET 3.5 framework was a prerequisite for SQL, which is in the configuration, and that machine is part of that configuration.
Now, can you have that fire alerts? So when it recognizes that a configuration has changed, it sends out some sort of notification?
It could be.
Okay.
I think you can do a lot. It basically writes every time it analyzes its configuration, it writes to a log file, and that log file is generated every 15 minutes.
Okay.
So you can actually have an add-on later on that says, okay, read all the log files in this directory from such. You can do it so you do it in a time window, right? So you're not reading every log file in the config directory because that can get pretty large pretty quick.
Right.
You would be reading, okay, if I have this agent executing every hour, okay, just read the last hour worth of log files. If there's certain keywords, then go ahead and fire off an email using an SMTP library that says, hey, configuration drift was detected on such and such machine, please, review. But that'll get logged that's verbose logging inside of those log files. So there is a record of when these things are getting changed. You can actually also make it a normal security practice just to detect any sort of tampering, that every week you consume all those log files into a parser, and you'll say, hey, Tuesday, it won't tell you who, but it'll tell you when. And then using another collection of tools, you can determine the who, or just if you have security logging on the server itself, you'll say, well, Sean logged in at 9:40. This change was committed at 9:50, and Sean was the only one logged in at the server. So it's more than likely that would happen.
Yeah.
Now, there's people that leave their sessions logged in all the time. We at Agile advise against it, but that can make getting that forensic information a little bit harder.
Well, we can go back, if you go back into our tech talks about maybe a month and a half ago, Andrea Fisher came in and was talking about Windows Advanced Threat Protection, and what we would later find out within like about a week after she did it was Azure Sentinel. So those tools that she introduced there would allow you to do that forensic analysis around who had modified the machines in a kind of post-active way.
Right. Desired state configuration actually is one of the more effective ways of doing configuration management, even more so than System Center configuration management. Number one, you don't need an agent to do it. It's baked into the technology. Two is that anybody that knows PowerShell will understand it. And three, which is the even more important one, you can actually build an entire system based on a single config file, right? You can say, hey, I need 4 SQL servers. Well, once the infrastructure is, this will not build infrastructure. So I need to make sure that that's clear. This goes on top of infrastructure, right? So if you needed to have, 10 VMs spun up with specific characteristics, and then certain PaaS services stood up and certain load balancers and all these different things, you can use ARM to do that. But this would complement ARM. Actually, this would complement ARM in a way where then you don't need to touch the machines getting, once the machines are built and the services are available, you would just need to qualify the endpoints with variable names, and then this takes care of hooking everything up. Now, the cool thing about this, if this wasn't interesting enough, is there's a depends by flag you can set. So if you have a multi-machine configuration and you need to make sure that SQL is installed on machine A prior to installing it on machine B, it can do that. It waits for its predecessor to be complete by having three basic operations. Test target resource, which basically says, hey, is this part of the config done? Set target resource, in case A said, no, it's not, make it so. And then get target resource, which is let's pull the configuration again after we've set it, right? Now that's any module for desired state configuration follows that architecture, which makes it really simple to follow and really simple to deploy because you have a set of preset operations that you know what they're going to be doing. Now the content of each one of those operations will vary because they're not going to be checking. You're not going to be checking the same thing for a SQL server and Exchange server,
Right.
but you're going to know what the module looks like. So once you look at one and you get intimate with it, it's quite simple to just keep replicating the pattern. Now, again, we have in Agile IT, we have in-house experts that are just doing that. I'm not going to say 24/7, but with certain frequency to help us grow our solution portfolio. So in case you wanted to make sure that, you have an app in-house that you want to deploy using this, we can definitely assist in building out your configuration and having it at the ready. Let's assume that your data center burns down, heaven forbid, if you're not in Azure. You can just stand up your config, stand up your boxes if you're in Azure with an ARM template, and then stand up your config using this, and then you're good to go.
So are we going to go into enterprise scaffolding now?
Sure, why not? So enterprise scaffolding is an interesting subject that's been brought up recently. It's basically, you and I were talking about it yesterday. It allows you to basically stock your tool set.
Yep.
It tells you what regions you can deploy to, what VM sizes you can use, what VM operating systems you can use, what particular regions or PaaS services you can use in what regions, and more importantly, what devices from the marketplace, if any, you can use. Why is that important? Well, Azure by itself is a huge a la carte offering, right? And I say a la carte because, yes, there are certain things that you can buy, but you can mix and match as whatever you want. So it's not a one. You don't just go in and I don't know of anybody that's gone to Azure just to buy a server, right? You may buy a group of servers or you may buy but you buy multiple of one. You buy different things in order for a solution to work. Those usually operate within the constraints of the resource group. The other thing that scaffolding allows you to do is be very declarative on okay, if you buy a subscription from us, you're going to get, access to these security features. It's going to be role-based access control out the gate. It's going to be accounts for storage out the gate, maybe one for backup, one for blog, one for diagnostics. All these things that, a company of our expertise in cloud will be able to bring up out the gate versus doing it as you go along, right? You have people that deploy VMs using just point and click in Azure, and that's fine. But then you go and figure out that, well, boot diagnostics isn't enabled by default after it crashed, right? So it's helpful to have those things deployed out the gate because it allows you to have everything logged and ready to go in a cohesive manner that the delivery experience is always the same.
And what I said yesterday was it's also important because it takes certain tools off the shelf. So I hate to bring up like the $175 in cognitive services I used setting up my first bot in Azure because I was kind of kludging around on my own personal account. And I'm a marketing guy. I didn't know what I was doing. So I over-resourced. So with the enterprise scaffolding, you can set specific resources that your admins or users can use, but that also removes the ability for somebody to build an overly large machine in your tenant.
Right. So, I mean, the other thing that people do constantly, and I'm in here all the time, is that people tend to think that they're on in-prem or in-house server will match the specs of a machine in Azure, and it will never match. If you have if you're buying a brand new server, you're probably not going to be moving your workloads to Azure, right? Because you have the resources in-house to do it, even though cloud is more accessible, but maybe, there's a reason why you bought that server to have that workload in-house. And if you have an old server, then that's the more reason to move up to Azure. But if you have an old server, you're not going to have the newer processors that Azure does.
Right, and this is what we talked about in the earlier tech talk about right-sizing your VMs and finding the optimal configuration for your specific workloads. Yep.
A lot of people use desktop. A lot of people use hefty desktop computers as servers, and that's not the same.
Mm-hmm.
The processor architecture is not the same. The generation of a CPU is not the same. Memory speed is not the same. Hell, SSD. There's all these factors that come into play that people sometimes don't account for. And the scary thing is, or the interesting part of this is that once they get their first bill, that's reality for them. That is, okay, well, I'm paying $3,000 a month in Azure consumption. That's just how it has to be. Maybe not. Mm-hmm. More than likely not. More than likely, you're going to be running on that $3,000 as an example for 2 months. Then you find out, hey, listen, I have this license enterprise agreement for Microsoft. Well, that'll save me some bucks, right? And then, oh, wait, now I'm saying that my CPU is running at 20%. Let's downsize it a little bit. So that's what allows you to do that. Right now, we're actually going to cut over to a demo that I had prepared for you guys. It's pretty simple, but it really cuts to the point as far as what you can do with with ARM templates. Pretty much what you do, the first thing you do when you get an Azure subscription, are we broadcasting this screen?
We are.
Okay, great. The first thing you do when you get an Azure subscription is, you get nothing. Well, first thing you do really is you go in here and you create a resource group. We've actually created one today for Sean. It says SS Demo. So as you can see, this resource group has nothing, right? So the first thing you do when you start in here, the majority of people, is they create a virtual machine. They need to start building, the blocks of what a solution is going to look like, right? The first building block you usually do is you build a virtual network. Well, what is a virtual network? Well, a virtual network, you need, what do you need a virtual network? Well, you need a virtual network for you to run your machines. Okay. Can you attach them directly? No, you need a subnet to do that. Okay. Well, now that I've got a VM and a network and I've got a subnet, what else do I need? Well, you're probably more likely going to need to connect them on-prem. So now you need a gateway subnet. Okay. And then what happens after the gateway subnet? Well, then you need a virtual network gateway and a local network gateway. So you guys can see how this evolves quite quickly and linear, right? There's a certain path, there's a certain evolution of these things. Wait a minute, Miguel. Well, I'm also going to be running a web app that I'm going to have exposed to the internet. Well, then you probably want a different subnet than the way you're going to be connecting on-prem. So all these things come into play when you're looking at this. So what the solution is for that is you would have an ARM template like this one that I've pre-built. So this is the visual ARM template generator, by the way, from Azure. So all I did is I took the word template and I went in here and I basically copied and pasted my template to here. And you can now see, as soon as I hit save, I get the deploy template screen. What this does is this allows me to select the resource group that I'm going to be deploying my template to. And it parameterized a couple of things. What did it parameterize? Well, first off, the name of the virtual network, which I want to call it Spicer VNet. And I want to leave everything else the same. The DMZ subnet's going to be named DMZ. The OBM, out-of-box management, it's going to be named the same. You have console access to all the resources manager, but if you have a network device that you want to have a separate interface to manage it, you probably want to have this built out the gate versus coming back and adding it later. And then you have a services subnet, where this is where you will run your Exchange, your SQL, your Active Directory, but you wouldn't run necessarily your IS boxes. Maybe you want to have a network security group in between. You can do that. And then it's like, well, what's the IP address going to be? Well, we chose this arbitrarily, but you can do whatever you want. So let's assume we're going to change this to 10. 10.00.6/16. Why such a big subnet? Why such a big network? Well, have in mind this is a network. There's subnets underneath, right? So this way you actually have 254 subnets at 254 hosts per, well, 251, I'm sorry, because the virtual network deployment actually takes 3 IPs per subnet to function correctly. But after that, you just hit agree, you hit purchase, and something will go wrong. It always does. It goes into validation, and then you can see here deployment in progress. Now this goes fairly quickly. It says deployment is underway, and then we'll just say, oh, it's done.
Wow.
So now we go to our resource group, and we identify that Spicer VNet has been built. Okay. All right. Well, I mean, that's not, I could have done that manually. Yeah, you could have done that manually, but you see we did 10.10.0016, right? That's what we put on the template. But wait, we actually now have subnets in here. Pre-address space allocated per product line architecture that you can start plugging in machines immediately into these gateways. Now, let's assume that you wanted to add, you know, a gateway. And I didn't script this part, but you can see how it goes pretty quick. So VNG, choose a virtual network. So it's already, all these networks comply with having a gateway subnet so it can actually connect into. If it didn't, it wouldn't even show up, right? So that's the beauty of it. And you know what? If we wanted to go ahead and delete our VNet or whatever resources on top of it, we can recreate it as many times as we want. Because we can then just go back to our deployments and say, oh, well, you know what? I want to redeploy this as is.
Cool.
Okay. And you can do it all over again. So let's go ahead and do that. You know, let's go and go overview. Let's go do this, delete. Yes, I'm sure what I want to do. By the way, guys, that whole always typing yes may look tedious, but trust me, it is a good assurance of, do you really want to do this? Okay. So now we go into the deployments again. We go to the template. We go to redeploy. See, with the exception of this, everything was redone. Now, why is this not sticking? Because we have this as a variable that feeds other ones. So that would need to be redone all the time.
Okay.
It's by design. Now, if we look at edit the template here, you're going to see default value string, but then you're going to see VM address prefix. Okay, this is a variable. This is not a parameter. And then we use this VNet prefix to feed these other ones and create them.
And now one of the things we discussed yesterday is you don't need to be able to write these by hand. So you can go in and, as Jason calls it, whenever I'm doing something, it's clicky. So you can go through the Azure GUI, create a resource, and it will generate a JSON template that you can then use and move into Git.
As long as you do it atomically, what that means is, for example, if I go into my Sean Spicer demo, okay, well, that's not going to work, but let's redeploy it real quick, just so you see what I'm talking about. Well, difficult. Super difficult, huh? Deployment in progress, deployment template, Shell Spicer demo environment, overview, deployment succeed. Hey, it's back with a vengeance. You just click on it, hit export template, and it'll build the template here for you.
Which you can then move into Git, GitHub, Azure DevOps, so that you can have that source control, right?
Right. Now, here's the different thing about this and the other one. You can add this feature is not out yet, but then you can add them to your library in Azure.
Nice.
So you can have them at the library subscription level, and this will allow you to basically, have a collection of all the scripts that you've done or ran during the tenure of this subscription, or your tenure with the company, or the lifetime of whatever.
And does that library have any features of source control? So
It
can you track changes?
it is just a
folder?
a folder.
Okay.
I'm not sure what plans Microsoft has for this. Probably integrating into a build pipeline of some sort. That you can say, okay, we'll build it in DevOps and then we'll publish it to Azure and it'll probably mysteriously show up in the library. I don't know. This just started popping up here a little bit ago. Microsoft's been pretty hush-hush about it. Now, look at the things here is template parameters. If you want to do command like Azure CLI, this translates into Azure CLI. If you want to do it using PowerShell, you can. If you want to use it as .NET calls, you can.
Nice.
So really, you're not just constrained to this JSON declarative language, even though it's the more supported one. You can use whatever you want. However, let's assume that we keep adding resources to this resource group. Your template will keep growing because the template is generated at the resource group level. So just be careful that I would suggest that every time you're building something, before you actually click build, hit generate template. And that'll allow you to know what you did. Now, let's assume that you built something works great. You probably want to tear it down and rebuild it again and have a template for it. It's sort of like your insurance policy if things decide to go south one day. You can do without it, but it's, as you can see, it's a lot easier to do with it in place. So that's it.
Awesome. Well, thank you very much, Miguel. Pardon me. There's that voice I was talking about. Thank you very much. I'm going to go ahead and cut off the recording here in a minute. For those of you watching on YouTube, we do have links to the full write-up on this down in the description below. Please give us a like and a follow. And thank you again for joining us for Agile IT Tech Talks.